Hi, in this class we will be studying basic concepts of organic chemistry. Organic chemistry is based on carbon, and carbon tends to form 4 covalent bonds. It prefers sharing of electrons, and in sharing of electrons the bonds which are formed are called as covalent bonds. Now, this concept can simply be stated as that carbon is tetravalent. Tetravalent means that it tends to form 4 bonds. If you consider any organic reaction, let us say reactants tend to give products, and on both sides you have organic compounds. In this case carbon is forming 4 covalent bonds, in this case also carbon is forming 4 covalent bonds. This changing of reactant into product is only possible if some covalent bond breaks and the other bond forms. On both the sides the number of bonds is exactly same, so there has to be a bond which breaks so that the other bond can form. Now, this leads to the first concept of organic, which is bond fission. Now, fission simply means breaking of bond. When a bond breaks, it is called as fission. This bond fission can be categorized into 2 distinct families. Let us say carbon has a bond with Y, it has 4 bonds and one of the bonds is with Y. Second scenario, again carbon has 4 bonds and one of the bonds is with X. Now, in first case, say this bond breaks in such a way that carbon withdraws its electron and Y also withdraws its electron. So, both have withdrawn their respective electrons. They were sharing electrons to form a bond. Now, they have withdrawn their respective electrons. So, this bond will break. So, this is the electron of the carbon, this is the electron of Y. This is termed as homolytic fission. Breaking of bond is bond fission. One of the ways the bond can break is homolytic, where both withdraw their respective electrons. Now, the species which is formed in this case, these are called as free radicals. Free radicals tend to have odd number of electrons. Electrons are always present in pairs, lone pair, bond pair, but if a single electron is present, then we call them as free radicals. Second case, say carbon has a bond with X, X takes both the electrons in this case. So, both the electrons are taken up by X. So, you will have carbon which is positive and X which is negative. Carbon has become positive because X has taken one electron from the carbon. Now, this kind of bond breaking is called as heterolytic. So, there are 2 kinds of bond fission, homolytic and heterolytic. In case of heterolytic, it is for sure that ions are formed, charged species. Now, if carbon carries a positive charge, it is called carbocation. This is one of the most important intermediaries, that is carbocation. Now, in heterolytic, there can be a second scenario. Say carbon has 4 bonds and one of the bonds is with M, and carbon being more electronegative than M withdraws these electrons. In this case, carbon will gain one electron and become negative, and M will lose electron and become positive. This negative on carbon, this is called carbanion. So, you have three basic intermediaries of carbon: free radical, which is formed through homolytic fission; carbocation, which is formed through heterolytic and carbon carries positive charge; carbanion, which is again formed through heterolytic and carbon carries negative charge. Now, there are many reactions in organic chemistry, but just think with logic that if reactants are forming products and on both sides carbon has 4 bonds, the bonds of reactant must break, then only the bonds of product can form. This breaking of bond can either be homolytic or heterolytic, leading to formation of intermediaries. Intermediary is something which is formed in between reactant and product. So, their intermediaries can be free radicals, they can be carbocations or carbanions. Now, from your exam point of view, you must know the hybridization of these species. In free radical, this carbon is sp2 hybridized. In carbocation also, it is sp2 hybridized, but in carbanion, carbon is sp3 hybridized. So, you must remember this hybridization of carbon atom in these 3 cases. In most of the scenarios, these two, that is free radical and carbocation, their stability orders are usually same, they move in same direction, and carbanion tends to move in opposite direction. So, the first topic, bond fission, I hope this is clear. It is very simple. Bonds of reactants must break and there are only 2 possible scenarios. Next topic will come to is classification of carbon. Now, let us say you have this kind of a molecule, this will be 2-methyl pentane. Now, this carbon is connected to how many carbons directly? So, as you understand, carbon tends to form how many bonds? 4. There are 3 hydrogens attached to this carbon. So, it can only be attached to one other carbon. So, this carbon is primary. Primary is written as 1 degree. Let us come to the next one. Let us say this carbon. Carbon will form 4 bonds, it has 1 hydrogen. So, it is attached to 3 different carbons. So, this is tertiary. This one again primary. This is attached to 2 different carbons directly. So, this is secondary, this is secondary and this is primary. Now, this concept of primary, secondary or tertiary does not depend on the length of the carbon chain. For example, let us say this carbon is right now secondary. Now, if I add one more carbon, let us say this is CH2 and this is CH3, this still stays as secondary. Now, if I add one more carbon, this is still secondary. So, it is not depending on the length of the carbons. So, these groups like CH3, CH2, CH3, CH2, CH2, CH3, etc. This is methyl, this is ethyl, this is propyl. So, these are generally written as R. So, if I have to represent a tertiary carbon, I can simply say carbon 1H and 3 alkyl groups. This alkyl group means it can be methyl, ethyl, propyl, butyl, because if there are 10 carbons in this line, there are 5 carbons in this, there are 7 carbons in this, still this is tertiary because it is directly attaching to only 3 other carbons. So, carbons are usually classified as primary, secondary and tertiary. In case of alkanes, you can have quaternary also. For example, if I take this carbon and this is like this is 2,2-dimethyl propane. Now, if you look at this carbon, this is attached to 4 different alkyl groups. So, this can be given as quaternary, but we would hardly use this. Now, I will just give you an example of this. You have CH3, CH2, CH2, CH2OH. This is butane 1-ol. Likewise, you have CH3, CH2, CHOH, CH3. So, this is butane 2-ol, and then you have CH3C, CH3, CH3OH. This is 2-methyl propane 2-ol. Now, this, the first one, can be categorized as primary alcohol. Why? To the carbon on which OH is attached, this one, this is attached to how many carbons directly? 1. So, this is primary alcohol. This carbon is attached to 2 different carbons. So, this becomes secondary and the last one becomes tertiary. Now, this is butane 2-ol. If you take pentane 2-ol, this is pentane 2-ol. Again, this is an example of a secondary alcohol. Now, this is ethyl, this is attached to a propyl 3 carbons. So, both are secondary because the nature primary, secondary, tertiary does not depend on the length of the carbon chain, and all these in general in chemistry are written as R groups. R stands for an alkyl group. I hope this is clear. Now, the next concept is nucleophiles. And electrophiles. Nucleophiles, negative or electron rich. So, in organic generally we do not use the word negative, we call them as nucleophiles. Anything which is electron rich or negative tends to be called as nucleophile. For example, Cl negative, OH negative, Br negative, Cn negative, they are all examples of nucleophiles. So, try and not use the word negative in organic, try and call them as nucleophiles. Now, you may have something which is neutral, yet it can be a nucleophile. For example, NH2, it has a lone pair, so it is electron rich. This also acts as a nucleophile. So, if they are asked what are nucleophiles, negative or electron rich species are called as nucleophiles. Likewise, diametrically opposite, what are electrophiles? Positive or electron deficient. Anything which is positive or electron deficient, we tend to call them as electrophiles. For example, nitronium, H plus, carbocation, you just studied, they all are electrophiles. Apart from that, you can have electron deficient molecules like BCl3, BF3, AlCl3, they are all electron deficient. Now, they are group 13 atoms like boron, aluminium, they have 3 electrons in valence shell. Now, if they share 3 electrons, so they will have only 6 electrons, and to complete the octet you need how many? 8. So, they are 2 electrons short. So, we call them as electron deficient. Anything which is electron deficient will like electrons. Electrophile, electro negative, phile means liking, electron liking. Who will like electron? Which is positive or electron deficient. Likewise, nucleus, nucleophile, nucleus liking. Nucleus is supposed to carry which charge? Positive. Which will like positive? Negative or electron rich. So, it is very easy and it is very simple. N for negative simply means N for nucleophile. In organic, we will not use the word negative, we will generally use the word nucleophile. I hope this is clear. Likewise, positive will be called as electrophile. These are few examples which are given over here. Now, let us come to this part which is given in your book. A covalent bond can be cleaved either by heterolytic or homolytic. So, there are 2 ways it can break. So, this is the example which is given in your book. There is a bond between carbon and bromine takes away both the electrons. So, this carbon positive, what is formed? Carbocation. Likewise, there is a bond between carbon and Z. Carbon takes away both the electrons. So, carbon will carry negative, this will become positive, this is called carba-anion. So, carbocation, carba-anion both are formed through which cleavage? Heterolytic fission or heterolytic cleavage. Now, this reaction, this is homolytic fission, both carbon which is represented with R and X, they withdraw their respective electrons. So, there is a dot, this dot is a free radical. So, this is homolytic fission or homolytic bond cleavage. This leads to formation of free radicals. Usually, when the reaction undergoes homolytic fission, it happens in presence of heat or light. So, this is how this is given in your book. Now, this topic deals with nucleophiles and electrophiles. So, this is the technical definition. A reagent that brings an electron pair to the reactive site is called as nucleophile, or you can simply say which is electron rich is a nucleophile, that is nucleus seeking, and the reaction is called nucleophilic. A reagent that takes away an electron pair from a reactive site is called as electrophile or electron seeking. A simpler way, electrophiles are positive, nucleophiles are negative, these are electron rich, these are electron deficient, and they have discussed few examples over here, and this is one of the questions. Giving justification, categorize the following molecules ions as nucleophiles and electrophiles. Absolutely no confusion, whichever is negative is definitely nucleophile. So, this is nucleophile, this is nucleophile, this is nucleophile, these are negative. No confusion regarding positives also, electrophile, electrophile, electrophile. Now, you are left with two species which are neutral. Now, this contains a lone pair. So, this is electron rich. So, this becomes a nucleophile. BF3 is group 13 molecule, boron, aluminium, they have 3 valence electrons. So, this becomes an electrophile and this becomes a nucleophile. So, these are your answers. These are all negative, this is also nucleophile and this becomes a electrophile. I hope this is clear. Now, let us come to the next topic. Inductive effect. Now, in inductive effect, first of all, this is a permanent effect. Let us say this long carbon chain is connected to chlorine. Carbon obviously has 4 bonds and the last carbon is connected to chlorine. Chlorine being more electronegative than carbon will withdraw these electrons. So, this will be delta negative, this will be delta positive. Delta means a small charge, this has small negative charge, this has small positive charge. So, you have studied this polar covalent bonds. If a covalent bond is formed between 2 atoms of different electronegativities, then one which is more electronegative will withdraw the electrons, which takes away the electrons towards itself will be slightly negative, the other one will be slightly positive. So, this is how this is happening. Now, this carbon has become positive. Ideally, the electrons between this and this carbon should be in the middle, but this has become positive. So, it will withdraw certain electrons. So, this will carry very small positive charge. This has become positive. So, this will withdraw electrons from this carbon. So, this will be very small positive charge. Now, after 3 carbons, this effect becomes negligible. So, we neglect it. This is a permanent effect in the molecule. This is electron withdrawing group. It is able to take away electrons from carbon, due to which carbon has become electrophilic. I hope this word is clear. Positive is called electrophilic. Now, any group or atoms which are able to take away electrons from carbon are said to have -I effect. This is a permanent effect which creates center of positive and negative charges in the molecule. So, inductive effect when an electron withdrawing group is present is called as -I. Now, come to think of it, let us say this is a long carbon chain. At the end of this there is a metal. This is less electronegative than carbon, this gives away electrons to carbon. So, this will be positive, this carbon will be negative. Because it is negative, it will repel electrons. So, delta negative, this will repel less electrons, delta negative. So, this carbon this time has become nucleophilic, and this group is giving electrons to carbon chain. So, this is electron donating group. So, to carbon chain you can have a group which is giving electrons, you can have a group which is pulling electrons from carbon chain. If it is giving electrons, then this effect is called plus I. Plus I would always mean electron donating, minus I will mean electron withdrawing. These effect minus I and plus I will create electrophilic and nucleophilic centers, which will be very reactive sites within the molecule. So, inductive effect is a permanent effect and leads to enhance reactivity of an organic species. Now, I will give you one example. You have CH3, CH2, Cl. OH negative attacks on this chloroethane. Now, this is your product. Now, why and how this product is formed? This will be delta negative, this will be delta positive, this will be delta delta positive, this is negative. Negative attracts positive. So, which is the most positive point in this molecule? The most positive point is over here, this carbon. So, this OH it goes and interacts on this carbon and it replaces Cl, Cl negative goes off. This reaction is called nucleophilic substitution reaction. Now, all of you understand substitution when one thing is replaced by other. So, in this case Cl is being replaced by OH. Why this is called nucleophilic substitution? Because negative replaces negative. Negative cannot replace positive. Negative and positive will join together. If negative replaces negative, one nucleophile is replacing other nucleophile, then you call those reactions as nucleophilic substitution reactions. If somebody is going to ask me why this reaction is happening, because this Cl has created an electrophilic center on which this OH can go and attack. So, this is the reason why this reaction is occurring, and this is the significance of inductive effect. It creates centers of positive and negative charges, which we call as electrophilic centers and nucleophilic centers respectively. So, this is the definition of inductive effect. This is how they are given these. The polar CCl bond induces polarity in adjacent bonds. Such polarization of sigma bond caused by polarization of adjacent sigma bonds is referred to as inductive effect. This effect is passed on subsequent bonds also, but the effect decreases rapidly as the number of intervening bonds increases and becomes vanishingly small after 3 bonds. So, here is an example of electron withdrawing and electron donating groups. Halogens, nitro, CN, they can pull electrons from carbon. So, they have, these are groups having minus I effect, they can pull electrons. On the other hand, the alkyl groups like methyl, ethyl are usually considered as electron donating, which I told you we write as R. Alkyl groups, they can give electrons, so they are called as electron donating. I hope this is clear. Now, we will come to the concept of relative stability of carbocations. We had studied carbocation which was formed through heterolytic fission, if you recall. So, this is how carbocation forms, heterolytic fission, and the hybridization of carbon in this case is sp2. So, we have to discuss the relative stability of primary, secondary and tertiary carbocation. So, this will be our next topic. But before we start with that, we will come to a more fundamental concept. Now, let us assume we have two spheres and they tend to differ in size. So, this is A and this is B. Both carry a charge of 1 coulomb. Now, if you are asked amongst the two which will be more stable, now both carry same charge 1 coulomb, they only differ in size. In case of B, because it has a larger volume, the charge density would be less. Charge per volume of sphere B is less because charge has spread over a greater region in case of B as compared to A. So, B is more stable due to lower charge density. So, if you concentrate the charge, it becomes more unstable. If you spread the charge, it becomes more stable. So, this is less stable and B is more stable. This is one of the most important and fundamental concepts of organic chemistry, which you will be using very often. You just remember this line: dispersion or delocalization, which basically means spreading. They have same meaning for science. Dispersion or delocalization of charge always leads to greater stability. So, dispersion or delocalization of charge will always make the species more stable. Let us assume there is another sphere C which has even a greater radius. If this also has a charge of 1 coulomb, then amongst A, B and C, this will be more stable. I hope this is clear. Dispersion or delocalization of charge leads to greater stability. Now, we will discuss the relative stability of carbocation. Relative stability of primary, secondary and tertiary carbocation. So, we will see which is more stable and which is less stable amongst carbocations. Now, carbocation is formed through heterolytic fission. So, it has 3 bonds. So, let us say if it has one alkyl group like methyl and 2 hydrogens, this carbon is attached directly to only one other carbon. So, this is primary. This carbocation it is attached to 2 different alkyl groups. So, this is secondary, and finally, you have a carbocation which is attached to 3 alkyl groups. We are taking methyl, it can be any alkyl group, you can write R also. So, this is tertiary, secondary and the first one is primary. So, there are 3 kinds of carbocations. You cannot have a quaternary carbocation because carbocation can have only 3 bonds. Now, if I take all the 3 hydrogens like this one, carbon H, H, H and plus, then you call it as methyl. This is a specific case. So, methyl means all hydrogens are there. So, for the time being we will discuss the relative stability of primary, secondary and tertiary carbocation. CH3 is an alkyl group. Alkyl groups tend to have electron donating effect, which is termed as plus I effect, which we just studied. So, they tend to give electrons. So, this means that in case of primary carbocation, one alkyl group will give electrons, in case of secondary 2 alkyl groups will give electrons, and in case of tertiary all the 3 alkyl groups will give electrons. Now, you have a positive over here. If this alkyl group shifts some electrons over here, then this positive charge will become less and this will acquire some positive charge. Look, this is an isolated body, this is an isolated body, this has a charge of plus 1 unit. Within this body, if this is giving electrons, some electrons to this carbon, the positive on this will become less and this will acquire some positive charge, this carbon. So, this means this plus 1 charge will spread in this much region. In case of secondary, this plus 1 charge is getting electrons from 2 groups. So, this plus 1 will become even less and positive charge will spread in this much region. In case of tertiary, if all the alkyl groups are giving electrons, this positive will spread in this entire region. An alkyl group decreases positive charge by giving electrons. There are 3 alkyl groups in this, there are 2 alkyl groups in this, there is only 1 alkyl group in this. So, amongst the 3, where do you think there is maximum dispersion or spread of positive charge? It is very obvious when you look at these figures that the maximum dispersion is happening in case of tertiary. So, the stability order of carbocation is tertiary is more stable than secondary, is more stable than primary, because in case of tertiary there is maximum dispersion of positive charge. Now, in this case we have discussed the stability of carbocation using inductive effect. A plus I effect stabilizes carbocation by dispersing positive charge. So, I hope you have understood this. This is important concept for organic chemistry, relative stability of primary, secondary and tertiary carbocation. In case you have any doubts from this lesson, you can ask me in person. Thank you.